The Charges and Fields simulation is an interactive educational tool designed to help students understand the principles of electrostatics. This simulation allows students to explore how positive and negative charges interact in space and observe the resulting electric field, voltage, and equipotential lines. By providing a visual and hands-on approach, the simulation enhances students' understanding of the fundamental concepts of electric fields and potentials. The simulation focuses on the principles of electrostatics, which is the study of electric charges at rest. It illustrates how charges create electric fields and how these fields interact with each other. It includes various tools and visual aids to help students explore these concepts in depth. The simulation allows students to arrange positive and negative charges in space. These charges are assumed to be pinned wherever they are placed, meaning they do not move once positioned. The electric field is displayed using an array of arrows fixed to a grid. The direction of the arrows indicates the direction of the electric field, while the brightness of the arrows indicates the magnitude of the field. This representation allows for a detailed discussion about the direction and magnitude of the electric field. The simulation also allows students to observe the voltage or electric potential at different points in space. Voltage is a measure of the potential energy per unit charge at a point in the electric field. Equipotential lines are lines of constant electric potential. The simulation displays these lines, allowing students to visualize how the electric potential changes across space. Equipotential lines are always perpendicular to the electric field lines. The Charges and Fields simulation provides a hands-on approach to exploring the principles of electrostatics. By arranging positive and negative charges and observing the resulting electric field, voltage, and equipotential lines, students can understand key concepts such as electric field, electric potential, and equipotential lines. The electric field is a vector field that describes the force per unit charge that a test charge would experience at any point in space. The direction of the electric field points away from positive charges and towards negative charges. The magnitude of the electric field is proportional to the strength of the charge and inversely proportional to the square of the distance from the charge. The electric field at any point in space is the vector sum of the electric fields produced by all the charges present. This principle allows students to understand how multiple charges interact to create a complex electric field. The electric potential, or voltage, is a scalar field that describes the potential energy per unit charge at any point in space. The electric potential is related to the electric field through the gradient of the potential. Students can observe how the electric potential changes as they move a test charge through the electric field. Equipotential lines are lines of constant electric potential. These lines are always perpendicular to the electric field lines. Students can observe how equipotential lines map out the electric potential in space and how they relate to the electric field. The direction of the electric field is indicated by the direction of the arrows in the simulation. The magnitude of the electric field is indicated by the brightness of the arrows. This visual representation allows students to discuss the direction and magnitude of the electric field in detail. The Charges and Fields simulation offers several educational benefits. The simulation provides an interactive and engaging way to learn about the principles of electrostatics. Students can actively participate in the learning process by arranging charges, observing the electric field, voltage, and equipotential lines, and discussing the results. Electric fields, voltage, and equipotential lines can be abstract and difficult to understand. The simulation provides a visual and tangible representation of these concepts, making them more accessible and understandable. Students can experiment with different arrangements of charges and observe the resulting electric field, voltage, and equipotential lines. This exploratory approach encourages critical thinking and problem-solving skills. The simulation provides a practical application of the principles of electrostatics, which are fundamental to many real-world phenomena, such as the behavior of charged particles, the design of electrical devices, and the study of electric and magnetic fields. This helps students see the relevance of these concepts in everyday life. The simulation introduces students to the process of data collection and analysis. By observing the electric field, voltage, and equipotential lines, Students can collect data and analyze the relationship between the arrangement of charges and the resulting electric field and potential. To implement the charges and field simulation in the classroom, teachers can follow these steps. Begin with a brief introduction to the concepts of electrostatics, electric fields, voltage, and equipotential lines. Provide examples to illustrate these concepts and explain how the simulation will help students understand them. Demonstrate the simulation to the class, showing how to arrange charges, observe the electric field, voltage, and equipotential lines, and discuss the results. Explain the importance of observing the direction and magnitude of the electric field and how it relates to the principles of electrostatics. Allow students to explore the simulation in small groups or individually. Encourage them to experiment with different arrangements of charges and observe the resulting electric field, voltage, and equipotential lines. Provide worksheets or prompts to guide their exploration and data collection. After collecting data, have students analyze the relationship between the arrangement of charges and the resulting electric field and potential. They can use the principles of electrostatics to interpret the data and draw conclusions. Facilitate a class discussion to share and compare findings. Encourage students to reflect on what they have learned about electrostatics, electric fields, voltage, and equipotential lines. Ask them to consider how these concepts apply to other areas of physics and everyday life. The charges and fields simulation is a valuable educational tool that brings the principles of electrostatics to life through an interactive and engaging context. By allowing students to explore how positive and negative charges interact in space and observe the resulting electric field, voltage, and equipotential lines, the simulation provides a hands-on learning experience that enhances understanding of these fundamental concepts. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of electrostatics in the real world.